Good morning, chemistry students. My name is Mr. Adam. This is chemistry, and today is the 8th of April. It is a Wednesday, and it is a day 5 in the schedule. So good morning, everyone. I hope you're doing well. I hope you're staying safe, staying positive, and still working hard on all the schoolwork that you have to do right now. I've been noticing a lot of people have been getting those assignments into me on time, for which I'm very grateful. Thank you very much. Those grades for the first 3 assignments should now be in on the dashboard. Most of you did pretty well on those. And if you got out of 25 points on those, if you got about 17, 18 plus points or higher than that, you should feel pretty good about where you are right now. I'm not looking for perfection on those. It's the first time you're seeing it, but I am looking for effort. If you got a lower score than that in total, I've already sent you an email to check in on you, see what you need. Always remember that when you're doing those assignments, you should be referencing things. You should be referencing your notes, the video, the reading that you did. You should be referencing me, right? You should be emailing me if you have any questions, if you're not sure how to do something. You can email me while you're doing the assignment, right? It's not cheating. It's not cheating to ask for help while you're doing it. We're trying to help you learn. And like homework, if you needed help on homework that you might ask your parents or your friends or me, you can do the same thing on these assignments, on these quizzes. So make sure to keep doing that, keep working hard, and keep trying to get better and improve. I am looking at those scores and I'm trying to monitor you and help you out, just so you know. All right, so today's lesson, we're going to spend a lot of time working on today's lesson and teaching you some things. Yesterday we talked about Lewis dot symbols. We said we had to use the big old periodic table, right, to find valence electrons, and then using those valence electrons from the columns in the periodic table, right? Using those valence electrons, we're making these things called Lewis dot symbols, which shows electrons on 4 different sides of an atom. Those electrons can be paired together, which we call lone pairs, or they can be unpaired electrons by themselves, just one electron. Now, these unpaired electrons, we're going to find out today, actually form bonds with other atoms. And when they form bonds, they combine together to form these things that we call Lewis structures. Now, Lewis structures, kind of fun to draw, but also really, really important. They're super important in biology because they show you, again, how atoms connect together, how they make up these big things called molecules, which are the things that make up our bodies, that make up our cells, that make up all the different parts of our cells. What you would see, actually, is that molecular structures and how molecules are fashioned, how they're built together, are really important for things dealing with viruses and with diseases, right? That's going to be really important. That kind of chemistry, that kind of biochemistry is going to be really important for dealing with diseases, vaccines. So all those researchers at Pitt and all the researchers around the world who are working on developing a vaccine for COVID-19 need to know that basic chemistry to understand all that kind of stuff. So it's really important that you guys understand a little bit about it too. Okay, so today we're going to draw some Lewis structures. If you want to watch this video while you're doing the assignment today, that would be perfect. We're going to go through a couple of these things called Lewis structures. What I want you to do right now is have a periodic table out. You can go to ptable.com or have an actual physical periodic table out. And I want you to open up the sheet posted on the Google Classroom that's called Steps for Drawing Lewis Structures. I'm going to write down the steps and show you them on these whiteboards here, but I want you to have that out and have that as a reference. If you can print that out, great, but otherwise just have it open as a tab on your computer while you're doing this assignment. It's super important that you look at that sheet and use that to do some of the problems today anytime it talks about doing a Lewis structure. All right, so go ahead and get those things out. I'm going to get my whiteboards. So we're going to do an example problem today. You have a couple problems, a couple assignments to do Lewis structures in your assignment today. And we're actually going to go through the second problem together, which is for H2O. Okay, so we have our chemical here, our molecule, which is H2O, just water. We want to figure out what the structure for water looks like, what it's built like, how those atoms are attached, and where there are lone pairs of electrons on things. Okay, so if you're looking at your steps for drawing Lewis structures, your first step, always, is to count valence electrons. Remember, this is a skill we practiced yesterday. So if I check out my periodic table and I find hydrogen right up here at the top, hydrogen is in group 1A. It's going to have 1 valence electron. So each hydrogen has 1 valence electron. Oxygen, if we scoot over here, oxygen is in VI or 6A. So what that says is oxygen has 6 valence electrons with it. So if I take that, I have 2 hydrogens and each has 1, so that's 1 valence electron times 2 hydrogens. 6 valence electrons from 1 oxygen. So if I add those all together, that's 1 valence electron times 2 hydrogens plus 6 valence electrons from oxygen equals a total of 8 valence electrons. Now, why are we doing this? Why are we not just connecting things together with as many electrons as we need? Well, each atom only contributes a certain number of electrons. It only brings a certain number of electrons to the pot, right? And so it can't actually bring any more electrons than that. You can't use any more electrons than you are given by your atoms, right? Okay, so you need to know the total number of valence electrons because you can't use more electrons than that. All right. Step number 2, pretty easy. You're determining what we call the central atom. The central atom obviously is in the center of the structure. It's the kind of thing that goes in the middle and holds everything together. Okay, so a couple rules for determining the central atom, because this can be a little bit tricky. Number 1, it's usually written first in the formula. Not always true. I wouldn't stick by that rule. Number 2, this is probably the more reliable one. There's usually only one of it in the chemical formula. What that means is there's usually only one atom of that kind. That's the central atom. So if we look at H2O, there's 2 H's, but only 1 O. So O is going to be our central atom here. Okay, carbon, it says, is often the central atom, and hydrogen is never a central atom. It always goes on the outside. So hydrogen can't be, so this is out, and oxygen, there's only one of it. So oxygen is going to be our central atom because there's only one of it. So we're going to say that oxygen is our central atom. And so when we draw out our Lewis structure, and I want you to do this along with me, have a piece of paper out if you don't already. I forgot to mention that, sorry. Have a piece of paper out. Thank you, Kat, for knocking my periodic table. Have a piece of paper out and be drawing that your central atom is O. So you're going to put that right in the middle, right? Okay. So just like this. Don't worry about the bond pairs yet, but you're going to put O right in the middle here, right? Okay. Step 3. Okay. You are now going to draw your structure. You're going to attach terminal atoms to the central atom. Okay. Terminal. We got to talk about what that word means. Terminal, if you've heard of someone who has a terminal disease, that means they're at the end. A terminal, like a train terminal or a station like that, means that you're at the end of the line. So terminal atoms are the ones that go at the end or go on the outside, right? So what you're going to do is you're going to take your oxygen here, you're going to attach your terminal atoms, your ones that aren't the central atom, and put them on the outside of the oxygen, right? So you're going to put them there, and what it says is you have to attach it. How do you attach things together? How are atoms attached to one another? What's that called? You should learn in lesson 3 that that's called a bond, right? And a bond is formed in molecules when atoms share electrons between them. For ionic compounds, they give and take electrons. But for these molecules, they're actually sharing electrons. So what you want to do is you have your pool of 8 valence electrons, right? We counted up how many we have. You want to keep track of these at all times. You have 8 valence electrons, and you want to attach the hydrogens to the oxygen with a pair of electrons each, okay? So you're going to put a pair of electrons, 1, 2 electrons, up, down, right? And these are representing a bond, right? Each bond has exactly 2 electrons, so there are 2 electrons per bond, and that means that those atoms are connected now. This hydrogen is connected to this oxygen, this hydrogen connected to this oxygen by those 2 electrons that form a bond. All right, don't forget to keep track of your valence electrons. So you started with 8, you took away 4 because you used 1, 2, 3, 4. Now you have 4 valence electrons left. It's really important for us. Okay. Number 4, we're going to fill the octet of the terminal atoms. Now the octet, it's kind of silly, we haven't actually learned this yet, but the octet that we're going to learn about in the next unit is called the octet rule. Octet, if you don't remember from learning a while ago, means 8, right? It's like an octopus. So an octet wants to have exactly 8 electrons. 8 is our perfect, happy whole number. So everything wants to get to 8 electrons. And so these things, these atoms and molecules, are going to share electrons to try to get everyone to 8. So you're going to fill the octet of terminal atoms. But of course, for this problem, we have an exception. Hydrogen, remember, is special. Hydrogen only wants 2 electrons. It doesn't need 8 because that first shell only fills up with 2 electrons. So hydrogen only ever wants 2 electrons, and that's why it only ever forms one bond, because one bond is 2 electrons. So if we look at this, Okay, this hydrogen has 2 electrons here that it can access. This hydrogen here has 2 electrons here that it can access. So hydrogen only needs 2, so hydrogens are happy in this molecule. So, look, terminal atoms are happy. What's not happy? The central atom. Oxygen only has 1, 2, 3, 4 electrons on it right now, and it needs 8. It's not happy with just 4. All right, so step 5. Keep following along. Keep drawing along on your piece of paper as you're doing this, right? Step 5, you're going to take all your remaining electrons. Remember, we had 4 left. All your remaining electrons and put them on the central atom. Okay, and you want to do that until it has 8. So I'm going to put 1, 2, 3, 4 electrons on oxygen, right? Okay, so I added 4 more. I had 4 left. I took away 4, so I have 0 electrons left. That's great. I want to get to 0 electrons, but what that means is I also can't add any more. I don't have the option to add any more whatsoever. Okay, if I look at oxygen right now, 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, right? It's good. So this is step 6. Check your octets. Do your hydrogens have 2 electrons? 1, 2, yes. 1, 2, yes. Good, hydrogen's good. Does your oxygen have 8 electrons? Yes, it does. Good. So your octets are complete. So this is your final Lewis structure, without the circles, obviously. But you have H, 2 electrons, O, 2 electrons, and H. Those are the bonds. And then there are these things called lone pairs. They're electrons by themselves. So if you looked at this, and you were counting the number of lone pairs and the number of bonded pairs on oxygen, 1 bonded pair, 2 bonded pairs. All right, so we have 2 bonded pairs, and 1 lone pair, 2 lone pairs. So the answer to this, as you would write it on your assignment today, would be 2 lone pairs and 2 bonded pairs. So if you watch this video, there's no way that you should get that problem with H2O wrong, right? Your final answer is 2 lone pairs and 2 bonded pairs. Okay, so that's pretty normal, easy example. I don't want to take up too much time in this video, but I do want to show you a little bit of a harder example, okay? So we're going to go through this together. We're going to go through the steps a little bit more quickly this time, but I want you to, again, follow along because this one gets a little bit trickier. All right, so now we have this molecule called CO2. You should all know this molecule. It's carbon dioxide, right? Step 1, counting valence electrons. Let's get our periodic table out again. And look, okay, carbon is in column 4A. I don't know how I can see that. IV means 4, right? So carbon always has 4 valence electrons. You'll get really familiar with carbon, hydrogen, and oxygen and nitrogen. Carbon has 4 valence electrons. Oxygen, column 6, has 6 valence electrons. That's a really good start for us, okay? So we have 1 carbon. It has 4 valence electrons. We have 2 oxygens, so we have 6 valence electrons times 2. 4 valence electrons from carbon, plus 6 valence electrons from oxygen, times 2 for each oxygen. 4 plus 6, 10, plus 6 is 16, so we have 16 total valence electrons. We got to use all those electrons. We got to satisfy the octet for everybody, make sure everybody has 8, and we can't use any more than 16 electrons, so we have to keep track of that. Okay, step 2, determining the central atom. This one's pretty easy. It is the first atom, and it's the one there's only 1 of, right? So 2 oxygens, only 1 carbon. Carbon comes first. Carbon is going to be our central atom, so we're going to put it smack dab in the middle, right? Okay, step 3. Okay, step 3, make the structure. Attach the terminal atoms with a bond, with a pair of electrons each, right? So my carbon goes in the center because it's the central atom. Terminal atoms, oxygen, go on the outside. We're going to put 2 electrons each in for bonds. Go ahead and do that on your paper right now. Okay, so put 2 electrons each in for a bond. Those are now attached together by a single bond, right? By a bonded pair of electrons. And remember that we used 4 electrons here. 1, 2, 3, 4. So we went from 16 valence electrons, took away 4, and now we have 12 left. Okay. Now, follow along. Remember, we want to get everything to 8, but our step 4 is to fill the octet on terminal atoms, right? So what we're going to do is we're going to take our oxygens, our terminal atoms, and start just putting electrons around them, right? We're going to put a pair of electrons on each side until they are full with 8, right? So we're going to put 1, 2, 3 pairs. 1, 2, 3 pairs on each oxygen. Okay? If you look at each oxygen now, you'll see that around this oxygen, there are 8 electrons. Around this oxygen, there are 8 electrons. That's perfect, right? That's exactly what we want. We have what we said satisfied the octet rule, right? Okay. We had 12 electrons left, and if you look at how many we used, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we used 12 electrons. So we have 0 electrons left. Now that's what we want. But that also means that we can't add any more electrons. You started with 16 electrons. You could only use 16 electrons. Do not use any more. You cannot just add electrons, okay? All right, that's perfect. We're exactly where we want to be. Terminal atoms are satisfied. We've used all of our electrons, but we have a problem. Okay. Number 5 says you put all the remaining atoms on the central atom. Did I erase that? Yeah, it's okay. All right, so put any remaining electrons. We don't have any left, right? We just said we have 0 electrons left. If we look at carbon, how many electrons is it attached to, or does it have access to? 1, 2, 3, 4. So carbon only has 4 electrons. How many does everything want to get to? What is our perfect happy number? 8. Carbon's not at 8, right? It's only at 4. It's not happy. It's very sad. So carbon wants to get to 8 electrons, but it can't. We don't have any electrons left to give it. We're all out of electrons, which is really sad for carbon. It needs 8, but it can't add anymore. You can't add anymore, right? Because you can't possibly add anymore. So this is where we start taking into account these things that we mentioned in lesson 2.3, which we call double bonds. If a single bond is one pair of electrons, so 2 electrons connected together, a double bond is 2 pairs of electrons, right? It's 2 pairs of electrons stacked on top of each other and connected. So what we're going to do, this might look a little weird and confusing at first. Remember that we had 1 pair, here, I'll pull this up. We had 1 pair of electrons connecting each oxygen to start. Now we're going to put another pair of electrons between each of those to form what we call a double bond. Now you might ask, Mr. Adam, you just said, I cannot add any more electrons. Well, I didn't, right? What do atoms in molecules love doing? How do they try to get enough electrons for everybody? What do? They share, right? So if you look right here at this oxygen, what it can do, it's already sharing 1 pair of electrons. Why not share another? So what it's going to do is it's going to share another pair of electrons. And this oxygen here is going to do the same thing. Okay, it's going to share another pair of electrons. And so what's going to happen is you're going to move this pair here, just cross that out, and put it in there. You move this pair here, just cross it out, and put it in there. Okay, so it's now sharing another pair of electrons. I didn't add any more electrons, I just shared. And so what that does is it creates this wonderful thing that we call a double bond, right? Where it's sharing 2 pairs of electrons. If you look, I still have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I still have 16 total electrons in there. I didn't use any extra electrons. But what I did do is I made it so that everything has 8. Everything is satisfied. Okay? So this oxygen, 8 electrons around it. Perfect. It's happy. This oxygen, 8 electrons around it. Perfect. It's happy. This carbon only had 4 before, but now because it has a double bond, because it's having 4 pairs of electrons shared between it, it's got 8 total electrons around it. So it's happy now. It's satisfied that octet. So when you draw the structure for this, if you draw it with lines instead of dots, you would actually see that there are 2 double bonds connecting each oxygen to each carbon. Okay. This stuff is a lot. This stuff's not easy. And what you're going to see is these lessons get a little bit more increasingly difficult. Lessons 1 and 2 probably weren't too difficult for you. But this one's going to take some practice. So when you're doing the assignment today, please, I beg you, actually take a sheet of paper, write it out, practice these problems, and get better at this as you go along, right? The only way to do this well and to get better at it is to practice it. It's one of those skills again, right? One of those skills that we only get better at with practice. So with Lewis structures today, you might not be perfect at it at the start. You might not get all the questions right, but take some time, practice it, write it out. There should be Miss Marnick's video, there should be this video, there's Khan Academy things to help you draw Lewis structures that might explain it a little bit better so you can understand it better. But practice with this stuff. Make sure you're getting better at it because it's a very important skill to understand how Lewis structures work and how atoms bond together to form these molecules. Okay? So work hard on this, practice it, read the steps, watch the videos until you get better at this, until you get the answer right. If you don't get everything on the worksheet right the first time, and the answers will be slightly off, so it might grade weirdly. But if you don't get everything right the first time, it's okay. Try it again. Figure out how to get it right. Okay? All right. That's all for content. That was kind of a very content-heavy video, but that's kind of what it's going to be more like now. So today, last thing I want to end on is the share of the day. So I want you to share today. It's Wednesday, so we're going to share a little bit harder one to share. I want you to share what you missed the most about school. Kate, I know you miss me, but maybe say something else, right? I want you to share what you miss the most. Either a person, or a teacher, or a friend that you miss seeing all the time, or just something you miss doing every day. Maybe you really miss lab days. Maybe you really miss going to gym and playing pickleball or anything like that. Maybe you miss just walking through the halls and saying hi to people. Maybe you miss eating lunch. Tell me what you miss about school at this point. Because, well, like we talked about before, we were all excited to get out of school. And then it was like, oh, yeah, it's kind of weird not being here. It's kind of missing out on a bunch of things. So share that with me. Work hard on these Lewis structures today. Please, if you are confused, send me any questions via email. I wish we could talk in person, but email is the best way we have right now. Keep working hard, okay? I will see you all tomorrow. Good job today. Let's get a 1, 2, 3. Clap on me.